Ever wondered where that sparkling favorite star of yours disappeared? Every one of us had a favorite star in the sky, which we would keep staring at the entire night wondering how sparkling and bright they are. But why do some of our stars disappear? Ever wondered where did they go? The culprit for the disappearance of your favorite star is a black hole. Before we indulge in the fascinating memory of a black hole, let's look at what a black hole is. A black hole is a cosmic body of intensive gravity from which even light cannot escape. Although black holes are often invisible to the naked eye, they can be seen via the effects of their powerful gravitational fields on surrounding matter. It is a place where matter is compressed down to an infinitely tiny point, and all conceptions of time and space completely break down. A black hole can swallow anything that gets trapped in its voracious gravitational pull. Stars, gas, dust, planets, moons, can all be swallowed by a black hole. How is a black hole formed? When a star dies, its strong gravitational field causes matter to be forced into a small space underneath it, trapping the light from the dying star. This process creates a black hole. The matter is compressed into a tiny space, which is why gravity is so powerful. We cannot see black holes because no light can pass through them. They are undetectable. Even though a black hole is considered to be a destroyer of celestial bodies, an attractive characteristic of a black hole is that it can retain information. Any scientist educated in quantum physics would tell you that nothing can escape a black hole, not even light. However, renowned British scientist Stephen Hawking proposes that information is still retained at the event horizon, which is the border of black holes. This is an incredible ability of a black hole. According to quantum physics, anything may be reduced to information, such as strings of ones and zeros, including matter and energy. Information should never vanish as a result of this rule, even if a black hole is swallowing up the matter or energy it is connected to. However, this theory goes against Einstein's theory of general relativity, which predicts that a black hole should obliterate the data. This is what physicists refer to as the information paradox. According to Hawking, the information never enters a black hole, hence it cannot be destroyed. Instead, it's trapped at the event horizon, the boundary in spacetime through which matter and light can only pass inward toward the mass of the black hole. The information is saved as a 2D hologram or supertranslation at this boundary layer. Holograms are 2D representations of 3D objects. Can information be read if it can be stored? Theoretically, if you could access this data in some way, you could reconstruct all the events that led to matter falling into the black hole. Consider a black hole as a paper shredder. Documents are torn to shreds and left meaningless, but if you connect all the pieces together, they make sense. The idea of Hawking radiation, photons released by the black hole itself as a result of quantum fluctuations, was first proposed by the same Hawking in the 1970s. Hawking first believed the photons conveyed no significant information, but he has now modified his opinion. There's a chance that information may leave the black hole using this Hawking radiation. The knowledge is lost for all practical purposes since it is in a chaotic, meaningless state, according to Hawking. How much information can a black hole hold? 1 gram black hole has information of 3,827 times 1010 bits or about 4.78 gigabytes. To give you an idea, even a gram of water holds more information than this. So far, we know nothing about the black hole's capacity to hold information. Researchers are examining what happens to data when it is stored in a black hole as well as how to access the data that is kept there. Using Hawking radiation and the strange idea of quantum teleportation, Aidan Chatwin Davis, Adam German, and Sean Carroll of the California Institute of Technology in Pasadena have discovered an explicit method to recover information from one quantum particle lost in a black hole. We have to wait until they come up with a sure solution. Do not forget to like, share and subscribe to our channel Explified.